Welcome back to Solving Radical Equations, Part 2. In this video, we're going to do some examples of that are a little bit more involved than the previous video. Some of these are going to involve factoring, okay, in order to solve for x, okay? But everything else is the same process, okay? Here we have the fifth root on both sides. So we have two radicals, right? And we're going to take the fifth root on both sides. So in order to get rid of the radicals, okay, we are basically going to raise both sides to the fifth power. All right? And that way we can get rid of the radical. So the fifth root on the left side is just going to be 5x minus 17, and then the right side is just going to be 3x minus 7. Okay, so we can quickly get rid of the radicals. Now we need to get all the terms on one side, okay, and so when we do that, I'm probably just going to subtract the 3x here. That way that cancels, and then you're just left with 2x minus 17 equals minus 7. And then I'm just going to go ahead and add the 17 to the right. So that cancels. Then you just have 2x equals minus 17 plus 7 is going to be 10. And then we're going to divide both sides by 2. And then I'm going to have x equals 5. So that one was pretty straightforward. Okay, x equals 5. All right, the next example. We have radical x plus 4 plus 2 equals x. Again, the first thing I'm going to do is isolate that radical by subtracting 2 on both sides. So that cancels. Then you just have x plus 4. And then on the right side, we really can't do x minus 2, right? Because they're different terms. So we're just going to write it just like that, x minus 2. And then we're going to proceed to squaring both sides to get rid of the radical on the left. Okay? So when we do that, we can just go ahead and square both sides. And then now everything under the radical on the left falls. So we have x plus 4 equals, and then the right side becomes x minus 2 times x minus 2. So we're going to have to FOIL over here, okay? We're going to multiply those two binomials. So when we do that, remember the FOIL, this stands for the first. So x times x is x squared. Then the outside is x times minus 2, which is minus 2x. Okay. Then the inside is negative 2 times x, which is negative 2x. And then the last would be negative 2 times negative 2, which in fact would give me positive 4. Okay? All right. So now we need to get, you notice that we have a squared term and an x terms, right? So we're going to get a trinomial, okay? So we're not going to be able to isolate any x term here. So when we have this situation, we're going to get all the terms on one side, and the other side is going to be a 0. So here's what I'm going to do, okay? The right side, we're going to do minus 2x, which is minus 4x plus 4. All right? And then now we're going to subtract 4 on both sides. So then you have x equals x squared minus 4x. And then now we're going to subtract x on both sides. Whoops. Oh, that's not working here. Because we want that to cancel. And then you just have 0 equals x squared minus 5x. So now we have a binomial on the right side. Now it's already equal to 0. The reason why we want all the terms on one side so that it equals 0 is that we're applying the zero product property, where if something is equal to 0, then the product of those two equal to 0. So what we're going to do here is we're going to take out a GCF on the right side. All right, so we're just going to kind of extend the problem. We're going to do it up here because there's a little bit more room. So we're just going to rewrite it over here. And what we want to do now is we want to factor a GCF out. So factor the GCF. And the GCF in this case is just going to be an x. Okay? Then we have x minus 5. So when we factor out a GCF, we want to take out the lowest exponent when it's the same variable, and x to the first power here will pretty much be what we have to factor out. Okay? And don't forget, this is still equal to 0, right? So now we apply the zero product property, where if x times x minus 5 is 0, then we can set both of those individual factors to 0. Okay? So for this particular step, okay, we're going to set both factors to 0. I don't know why that's not doing that. Okay, so the first factor, x, again, we're going to set equal to 0. And then now we're going to do x minus 5 equal to 0. And all we got to do now is solve for x, okay? So, again, we already have one solution, x equals 0, so there's not much you can do here. But over here, we can solve for x by adding 5 to both sides. So these cancel, and then you just have x equals 5. And that would be your other answer. So you have two solutions for this because it's a quadratic equation, it's squared, okay? So yeah, there was a little bit of a process because you had to factor it out and then set both factors to 0. Okay, let's do another example. Okay, notice that this particular example, we can't really do anything with the 1 on the right side, so whether we move it on the left or keep it on the right, it's not going to have no impact on simplifying anything. So I'm going to go right to my next step. Both radicals are square roots, so I'm just going to go ahead and square both sides. All right, I can just go right to that step. All right, when we do the left side, that's just going to be x minus 2 equals 1 plus square root of x minus 7 times 1 plus square root of x minus 7. We really can't drop the radical in this case because the whole thing is not under the radical, so we're going to have to FOIL this out, which will still work, okay? Here's what will happen is when we FOIL this out. All right, so we're going to do 1 times 1, which we all know is 1, plus, and then we do this 1 times square root of x minus 7, which is just radical x minus 7. Okay. And then now we do the inside. Again, that's just going to be a plus radical x minus 7 again. Then we're going to multiply radical x minus 7 times radical x minus 7. And when we do that, that's when we can drop the radical, remember? Because why? Let me show you the step. It really becomes this. Sorry. It really becomes this. Right? We're multiplying those two together. So everything stays the same. So what this becomes is, without skipping any steps here, we can just write this without the radical. Does that make sense? Because we're squaring it, okay? And now when we combine like terms on the right side, okay, don't forget there's an imaginary 1 here, right? So when we add those up, it becomes 2 square root of x minus 7 plus x minus 7. Okay? All right. So now what we want to do is we want to go ahead and simplify on the right side. We can go ahead and combine some terms over here, can't we? So we can go ahead and do 1 minus 7 on the right side. That's going to give me minus 6. So let me just go ahead. Yeah, minus 6, right? 1 take away 7 is minus 6. And then now we can actually add the 2 on this side. So that cancels. Then you just have, whoops, x equals 2. I don't know why my pen's not registering here. Minus 6 plus 2 is minus 4. And then we can go ahead and cancel the x out. And that's going to give me 0 equals 2 radical x minus 7 minus 4. And now, in order to get rid of the radical, what we can do is now we're going to add the 4 to both sides. And my pen is being so stubborn here. So, I don't know why it's doing that. So that cancels, and then you have, okay, we're going to go back over here because there's more room. 0 plus 4 is just going to give me 4, okay? 2 radical x minus 7. And the minus 4 plus 4 cancel on the right. Now, we have the radical isolated on the right side. And now we can go ahead and raise both sides to the second power. Yes, I know this is a lot of steps, because the 1 plus square root of x minus 7 wasn't easy to work with. 4 squared is what, 16? I'm sorry, 4 squared is, I forgot a step. So I'm going to have to just re-erase that. Okay, I forgot one step here, and that's going to be 0 equals, and I'll show you what I mean. This is what we got, right? I wanted to divide both sides by the 2. Okay. Why did I do that? That meant to say 4. Oh boy. I made the 4 just disappear. It's 4, right? Because 0 plus 4 on the left is 4. Okay, so when I divide by 2, that reduces to 2. 4 divided by 2 is 2, and this reduces to square root of x minus 7. And then, finally, we can square both sides. And when we do that, now it's really simple. 2 squared is 4. This just becomes x minus 7, and all I got to do now is add 7 to both sides. 7 and 4 is 11, and then that equals x. And finally, we have the answer. Okay, I'm sorry for the little mishap there earlier, but hey, it's fixed. We identified what went wrong, and now 11 is our answer. Okay, so it's a little bit of a process with this particular problem because of the 1 plus square root of x minus 7. It doesn't just cancel out immediately, so we have to do some algebra, okay, along the way in order to keep simplifying it. So patience is a virtue with this problem, and as you can see, as I was working it out with you, there's a lot to do here, a lot of algebra to keep in mind, okay? But it's not difficult if we just break it down step by step, doing it very slowly and methodically. That way, if we make a mistake or an error, we can correct it and say, okay, this is what we need to do, or this is what we forgot to do, and then fix it, okay? And that's what math is all about. It's just a process. Sometimes there's a few bumps, but, you know, identifying those bumps, kind of going along with the ride, if you will, and then just fixing them. And that is the magical power of mathematics, okay? We can go ahead and figure out what we did wrong, and then everything will kind of fall into place. All right, so that one required some work, okay? Okay, so I think that's the last one I wanted to show you. So I hope that you were able to understand the process of solving radical equations. I hope this was very helpful to you.